And so Agentic AI Foundation. So this is intended to be a foundational class. There's a larger Musa Labs educational series that goes a little bit deeper than what we're doing today. But the goal of today is to talk about like, hey, how are we building enterprise agents? What does best in class look like? And how do we take something from zero to production? And so the intent is that you're going to leave from this session with an agent that is unique to you, and that way you can continue developing even after today. And at the very least, you establish a good foundation for how to build strong enterprise agents. Just real quick, one thing that I'm very passionate about right now that I just wanted to communicate to this group is that the landscape in venture capital and company formation has completely changed with AI. I think everyone's feeling that, but I don't think people recognize how real this is. Um, the anatomy of starting a company has completely flipped and completely changed, and it starts with your enterprise agent. Because your enterprise agent is not just an agent that provides a solution for an end user. Enterprise agents are also internal resources that are used to build your products and your companies. And so this is now the effective employee replacement that has arrived. And if you don't know how to do that, if you don't know how to replace people with AI, then that is what Musa Labs is all about. Because ultimately, like people, sorry, let me turn off my ringer here. People have all of the context, but AI should be doing all of the execution. And that's largely what enterprise agents are really strong at. And so, at any rate, not getting too far off onto the tangent. What is today? So most AI workshops are slides and a pitch. This is a build session. So the intent is for you to lead with a working agent, build yourself, and the why behind it. So to understand the anatomy behind the agent, how to build it, how to reproduce it. So hopefully you leave with something that's usable going forward from here. But if not, you can recreate your own and something that's more usable in either your internal workflow or your product. And so we are going to build the base, right? An agent that calls tools, runs them in parallel, handles failure. That's something we're going to do together. Jeez, sorry. This is okay. So, next, we're going to make it yours. So I'm going to provide a general example to the group. Then we're going to customize it. Everyone's going to customize the example to make an agent specific to your own unique use case. And then you get to keep it. It's yours. I will be providing the resources for today. We have a Claude API key that has around $45 on it. Please do not abuse this API key. Okay, it's only available for today. I wanted to make sure that everyone has resources to build. If you have your own API key, please use that. If not, no worries. One will be provided for you. So, what an agent actually is. So, if you strip away the agent is a model in a loop with tools. We'll get into what the loop looks like, as well as what the tools look like and how to define them. But pretty much you ask, you send a message, the tools that it may use, the agent decides like what model needs to be used, what tool needs to be called. It then runs the loop and then provides you your answer. That is effectively what an agent is. And you can pretty much permeate that across any function, any operation. But that is the core essence of an agent. And so when people talk about like enterprise agents, it's nothing super complex. It is like literally just organizing AI operations to deliver an outcome in a structured way. That's all. And FYI, if anyone has questions, don't hesitate to raise your hand. Like, we'll try to keep you on pace, but we have about 15 minutes. Sorry, got a question, Negro?
No, sorry about that. I'm going to go.
So, model architecture, the production architecture, the same loop with four parts that make it hold up when real users touch it. So, people always ask me, I don't say always ask, but people sometimes ask, what is the difference between an agent and a script? Like, what's the difference between an agent and just something that you code, right? Like essentially a coded execution outcome. And the answer is flexibility and failure with grace. That's pretty much the only difference. But those are two really big differences. And so, what allows those differences is these four components. You have the brain, which is the model, right? There's lots of different models. You can use Chat 5, you can use Claude Opus, you could use Claude Fable, right? It depends on what you need. But this is the model you choose is determined on the type of reasoning that you need for the agent and the type of execution outcome that the agent's also going to be utilizing. Um, does anyone know why choosing the right brain for an agent is important? Just go ahead and raise your hand if you think you have an idea of why that's an important thing. All right, Toshiba, what's up?
Hi. Can you hear me?
Tasbiha, excuse me,
Yes,
Tasbiha.
no worries. Can you hear me?
Yes.
Okay. I think the models, like I've used ChatGPT and specifically like some of them are like instant. So it also depends on the how much data power you're using. If you have instant, then why use the advanced like longer? And Claude and when you talk about agentic AI, it requires a lot of API and tokens difference.
100%. So the way I would synthesize that down, which is 100% correct, and I'm just going to go ahead and lower your hand for you, but you're good, is effectively that token. Who's heard the phrase token maxing, right? That's not what we want to do. Token maxing is not it. Token optimization. So how expensive is the agent that we're running, and what do we need it to run? Like, why are we going to use Fable 5 if Opus 4.5 will do, right? Why are we going to use Chat 5 if Chat 4.0 is good enough? Because that's the difference in cost. That's the difference in margin, and every single agent execution hits that margin. Not only that, sometimes if you choose the wrong model, right, for the wrong task, if you need to do an advanced task and you choose a dumb model, the agent's not going to perform well, right? And so there's an equation here of choosing the right brain for the right time for the right task, right? And then ultimately the tools, right? Functions it can call to act. You'll write your own today, by the way. And FYI, no coding knowledge is required. Because why is no coding knowledge required in order to build an agent? Anyone from the audience? Let me ask a different question. What has AI enabled that has leveled the playing field between engineers and non-technicals?
You can learn everything like I've learned. You can, if you have a stuck in the code, you can share the error and it can help you step by step and you can do it. Like I've been afraid of coding and AI helped me learn coding.
1,000%. I would take it even a step further. I'm pretty extreme. I would argue no learning involved.
Oh no, I particularly make sure that there is a learning. In my class, someone like my teacher told me that X people start doing Excel like empty shells, but I learned how to calculate p-value with Excel. For me, AI has helped me as a coach or like if you want to learn new things, it helped me bridge that.
Okay, I have a question for you.
Yes.
Tasbih,
Yes.
what is 1,041 divided by 17?
Okay, wait a second.
No, already failed. Already failed,
Okay.
right? So listen, I have no doubt that if you wanted to, you could do that calculation. No doubt, right?
Yeah.
But like whether you can or you can't doesn't matter to me. Do you know why? You have a calculator on your computer.
Yes.
So no matter what, and we have told our and so that's the other thing is if I asked you to do that, I told you to give it to me the quickest way possible. What would you do? 1,041 divided by 17. How would you? What's the fastest way you get me that answer?
I'll do the calculation with calculator.
1,000%. It's the fastest
Yes.
operation. But hey, what if I told you that the calculator could hallucinate?
What?
Yeah, yeah. What if I told you the
Oh,
calculator could hallucinate? What's up?
then I use ChatGPT.
ChatGPT hallucinates too. So like,
Then I'll do myself.
okay, exactly right. So like, that's what we, if we do not trust our tools, we're gonna do it ourselves, right?
Yes.
Like that's like the crux of that. If we do not trust our tools, we're gonna do it ourselves. But if we trust our tools, we're gonna let our tools handle it to deliver
Mhm.
us the right answer the fastest way possible, right? And
Yeah.
the only reason why right now, as humans, we are insistent on learning all of these different operations is because we don't trust AI. We know AI hallucinates. We know AI can be wrong. So there's this feeling that you need to understand the why behind the AI execution. Otherwise, it's cheap, it's cheating. But we use calculators all the time because we know how to do math. I'm just using a faster shortcut. But if I told you that that calculator could hallucinate, you would think differently about using that calculator. Now, as soon as we get confidence in our AI systems that they're no longer hallucinating, are we going to do it? Are we going to do it ourselves? Absolutely not. We're going to let AI do it. The only reason why we're concerned about the learning today is we don't trust the AI systems. So you know what? I would rather know how to do it so I can double check the AI. But the reality is, Fable 5 is already better at coding than you are. And it's a
Mhm.
fact. And you'll never be as good as Fable 5. Even if you started today, even if you worked as hard as you could, try to learn as much as you could, Fable 5 is just better than you. And so I get that we want to learn the why behind things, and we're going to learn the why behind things today. But like, mm, not important. Uh, what's important is that things work.
Mhm. Yeah.
What's important is that we're able to get things to work.
Yes.
How they work, that's going to be important to a degree. And I would say the more context you have around that gives you an advantage at building more sophisticated things, but it's not a requirement to get started. And so one of the things I'm going to show you today is like how we triage through problems, right? Even if we don't know what's going on. And so the other, just getting back to the core content, right? The other piece is the core memory, right? The conversation, the context it works from. And the last element of the agent is the control, the limits, the failure handling, safety net. We're going to build all four together today, right? So don't anyone worry. You're left behind. We're going to be all right. Let's see what time is it? About 40 minutes. Here we go. Okay, your first agent. Build one tool, build the loop, get a win. All right, so I'm going to post something in chat. Let me just go and look at the screen. Are you guys still seeing my slides or are you seeing my screen here? What are you seeing?
Slide. Build
Okay,
checkpoint one.
it's okay. No worries. All right, it's fine. We'll correct that here in a second. All right, let me go ahead and find. Okay, in chat, I'm posting a link. So everyone, you got to navigate to the video, to the chat feature inside Zoom, and you're going to be able to research a collab document, right? This is a Google research document that has an AI agent already built with an API key, a Claude API key already public. For those savvy on the call, this is going to get turned off immediately after this session. So don't you go pasting that API key nowhere, all right? However, for folks that if you have your own resource and want to use your own API key, please use that, right? If you don't, feel free to use the API key that's inside the tool. It should be it should be enough for today's session. I just know folks are resourceful now. Okay, listen, it is what it is. I'm not gas is expensive. Okay, and so let me stop sharing and then now reshare my screen. What happened? Here we go. Okay, so this is what everyone should be seeing now, right? This is effectively this is an AI agent that was pre-written for today's example, and this is going to allow us to go through the anatomy of an AI agent, and then we're going to customize this in order to produce a unique agent that you can then, continue on in terms of development, right? So first, checkpoint one, is everyone able to pull this up? Is everyone able to
I
pull
have
this?
a different code. I have a different code.
What do you mean? What do you mean different code?
I have a pipeline install anthropic and fake weather. I have a fake weather different code.
Your fake weather is different? You sure?
Oh no, sorry. This is second code. Sorry, my bad. I have a second page. Sorry. It's
No,
fine.
no, you're fine. Okay,
Uh,
okay, all right, good.
yes, sorry.
Just want to make sure that everyone's able to pull this up. Boom, we're able to find this. Okay, sweet, sweet. So,
Sorry, I can't, I don't have the link.
no worries. Let me go ahead and are you able to navigate to the chat feature inside Zoom? If you want to
Yes.
find the chat feature inside Zoom, I'm going to go ahead and paste the link inside that chat feature. Okay. I'm going to posted it again. All right, perfect. Because this is really important. Everything's going to be built off of this workbook that we're doing here. So just want to make sure that everyone's able to access it. Okay, sweet, sweet, sweet. If you guys aren't able to like track anything, or you guys like aren't able to access anything, yeah, let me know. Raise your hand. Please don't be afraid to speak up. Okay. So this is an agent. It has an Anthropic API key. It should be ready to go, right? If you guys were to just do run all, right, just like on this book, and we're doing this run all function now, right? You'll see that it executes this first cell, right? And then it should print, hey, setup ready, right? And so now it's doing the Anthropic install. And then once it's done with the Anthropic install, it should hopefully like, okay, boom, setup is ready. Then it goes to this next key, right? Boom, check mark, tools ready, boom, check mark, agent ready, right? And then this last piece, right, is the actual like run function. So like I could edit this, but this is essentially what's being sent to the agent. And when we say, hey, agent, what is the weather in San Francisco? It says tool calls, one step, get weather, city, San Francisco. The current weather in San Francisco is 62 degrees, Father. Well, you might want to grab a jacket. So I wanted to just like call out like what is happening here with this agent execution. So this was our outcome, right? And our question to our agent was, what is the weather in San Francisco? So the one thing that we want to call out here and is for our is so for our tools, right? And so pretty much this starts our tooling definition. We have a couple of functions, right? We have get weather, right? We have calculate, and we have save note, right? And then for our tools, we have get weather, we have calculate, we have what was it? We have get weather, we have description, and sorry, yeah. So name get weather, and then name, sorry, calculate, and then name save note, right? And so each of these things, this requires this is what our anatomy of yeah. Let me just go ahead and go back to the slides real quick. This is our anatomy of a tool call. So the name, right, is what to call it, right? The description is the model reads this to decide when to use it. So so when does this tool get called, right? What is the input schema? Like, is this a string? Is this a number format? Is this a date? And then the return dictation, right? Like, what is it supposed to return? This is the anatomy, right, or the fundamentals of a tool call. And so if I were to reshare right? The collab, we have our name, right? Get weather, right? The description, get the current weather for a city, right? Input schema, type, object, right? City, type, string, required city. So what's required? You have to provide a city, and the city has to be a string. If we were to provide a number, that wouldn't work, right? And so the tool implement get weather, right, is get weather, calculate, calculate, save note, save note, right? So this is effectively like, how a tool, like these are when you ask for something, right? So when you say, hey, what is the weather in San Francisco, right? That weather triggers that get weather tool call. The tool calls are going to be dependent on the inputs that happen inside the agent inputs inside cell 4. I'm going to go back to sorry, I'm flipping back and forth between the material, and I just wanted to make it real for folks. And so there are three ways a tool call can get run. One is sequential, right? So A needs to happen, and then B, and then C. Sometimes you can run them in parallel, right? So, hey, let me get weather in two cities. Hey, I want weather in San Francisco and Toronto. And then one can be conditional, which is, hey, I want the weather in San Francisco. And if it's less than 50 degrees, do X. That's conditional. And so the build checkpoint two is we want to add two tools, right? And we want to save a note alongside the get weather. Let me just go ahead and just pull up the right example here. Ooh. Okay, here it is. All right. Stevie, you got a question?
Yeah, yes. The the tools cell, right, where the name and the actual process gets, yeah, there. So the trigger was the word, if the prompt contains the word weather, is that correct? And then it recognizes weather, which will then trigger off the first tool there to get weather description and so forth. Is that correct?
No, that's not exactly correct. So it's not triggered off of keywords, right? So when you provide an input to the agent, like what is the weather in San Francisco, it actually parses that and
Okay.
then determines what tools it needs. So it then determines that, like, hey, in order to execute this, I'm going to need to first do get weather. So it's going to call get weather. Then it's going to calculate, right? And then return that expression. So those and so that is and so that is where the agent brain decides what tools that it needs to be used. So that it actually parses the request and then through that determines which of these tools is needed to execute that request. Does that make sense?
Okay, then if that's the case, then like if I put in what's the time in San Francisco, right?
Yeah.
It would
Let's
then
do that.
okay.
See, and this is part of the agent failure framework. And this is what makes an agent different from a script, right? But it says, hey, what is the time in San Francisco? I'm sorry, I don't have a tool available to check the current time. And then it tells you what it can do. However, I can tell you that San Francisco is the Pacific time zone. So where does it get that, right?
Mhm.
So through the description, when this tool gets called, right? So effectively, your agent is going to look at each of these descriptions, and they're like, does this description match the request? Does this description match the request? You know, no, no, no. Okay. Well, then you know what? None of these tools match. But it can tell you this in PT, right?
Right.
To get the exact turn time, here's where you go. Is there anything else you need help with? Right? This is the failure that's like built in. This what makes an agent and not just a script. Does that make sense?
Yeah, so it's not running on the string variable that you input. It's just okay. So the AI, I got it. Okay, so the AI is recognizing that you're asking for the weather, and then the second
That's right.
asking for the time, and then it runs the tool for getting the weather. But there's no tool. We didn't have a tool for time. Okay,
That's right. Exactly right.
I see.
Prashant, you have a question?
Yeah, Alan. Thank you for explaining. So, does this mean that if you have 100 tools created, you pass down all the 100 tools to the model and the user query that's given, and
Yes,
the model decides which tool to be called? That's the thought.
1000%. Which
Oh,
is you should not do that. You should not do that. So exactly right. The more tools that you have, right, embedded in an agent, the less accurately it will know which tool actually needs to be called. There's too many
oh,
descriptions. You can have too many tools that sound similar or that like could be leveraged in a similar use case, right? Like 100 tools, it's very difficult to have like 100 discrete tools, right? There's going to be some overlapping functionality, trigger case, whatever it is. And so that's why like the architecture, the tool, you know, your tooling package for your agent becomes really important. And if you need a different tooling package, just create a new agent.
okay.
It's actually really fundamental, important thing about when it comes to overall agent accuracy. The more tools you have limits the effectiveness of that agent choosing the right tool. So this only works because we have 3 tools. And so it knows that time's not one of them. Right? If we had 100 tools, there might be one that sounds a little like time, and it decides to just
Mhm.
use that one. And then it provides us a result that's just not correct.
Cool. Got it. Thanks.
No worries. Okay.
Oh, wait, can I ask a question?
Yes.
Was this code that you provided written by an agent or written by you?
Agent, of course. So FYI, I'm non-technical. I'm going to be the first to admit that I am non-technical. However, I have built agent orchestration systems that we're currently leveraging in Lucid Capital. My own personal favorite way to leverage AI is I have an OpenClaw agent that is connected to my Amazon Fresh delivery account. And so every time I get an Amazon Fresh delivery, that receipt is then uploaded to the agent. It knows what it has in my fridge. Every time I consume something from my fridge, I take a picture of it, upload it to the agent. It then updates the inventory and provides me recommendations on what I need to eat based on potential expiration of the ingredients that are in my fridge, and gives me perfect macro counts at the end of every day. That's an entire agent system that I built being non-technical, right? Already lost 18 pounds, up 10 pounds. You know what I mean? Like AI is great. AI is great. And you don't need to, like, you just need to provide the guardrails and let it execute. Trust, but verify, right?
You trust it with your credit card?
No. Do I don't trust it. Does it have my credit card? Yes. Do I trust it with my credit card? No. Has it ordered me the wrong thing before? Yes. But has the benefit outweighed the potential detriment? 100%. So do I trust it? No. But it hasn't gone egregiously off the rails enough for me to rein it in. So, it maintains ownership. But this is a really good example. So one thing I wanted to call out here is, one second. Uh, So here, the input that we have, right, is what is the weather in London? Convert Phoenix temp to Celsius if anywhere is above 9 degrees. Save a note to pack for heat, then summarize, right? This is what we told our agent to do. And so I wanted to call here that at first it does two things, right, in parallel. It does get weather city, Phoenix, get weather city, London, right? But then it has a conditional statement, right? Expression 140, minus 32 times 5 divided by 9. Is that greater than 90 degrees? And the answer is yes. Okay, check mark, save note, pack for the heat is currently 104. Light clothing, stay hydrated, right? And so now, when we look at the summary of the actual agent, right, it provides us the output, right? 104, London 109. Heat alert, Phoenix is well above 90. So a note has been saved, remind you pack for the heat, right? This is both an example of a parallel tool call and a conditional tool call. And so if any one of these things, right, were to be different, then the output would be different. And then hold on a second. So the next thing that we want to do, wait, hold on a second. Wait, what's screen? Are you guys seeing the Agentic AI right now? You guys seeing the code?
Yes.
Yes.
Okay, all right.
Yeah.
So yeah, let's go back to the slides real quick. Okay. And so we saw there, right? Like, and we saw in the time example that the framework already handles failure, right? Real tools are slow, down, or wrong sometimes, right? And you saw that the agent survived. Like that is critically important. That is the advantage of an agent versus a script. When any tool errors, the framework catches it and then provides some type of graceful fallback mechanism. Nothing crashes. The model reads the error and adapt, tries again, or tells the user honestly what's going on. And that means that any tool you add, even the one that you create in the next 30 minutes, is going to be automatically protected. Okay. So, just real quick example, one more example I wanted to show. And then we're going to go to the create your own agent portion with the last 20 minutes. Okay, we're pacing about on time. Is here, we're going to turn this weather flaky true. And then, hold on a second. And then I wanted to go back to one of our initial inputs. This is it, sorry. Here, let me just grab it from this one, sorry. Original input is what is the weather in San Francisco? I just want to put this one in again. Okay, what is the weather in San Francisco? So if we were to rerun this, the only thing I did was I turned this weather flaky equals to true. And what is that supposed to? Okay, I didn't do it. Maybe I need to run it all again. Okay, yeah. So now we get it. So there is an additional element added here. So what we did is we turned this weather flaky equals true. And the reason why it wasn't giving me the correct result is because I needed to rerun this cell. So the agent state was reloaded from the weather is flaky equals true. Once I did that, say what is the weather in San Francisco? Tool card tools, 1 step. Weather blipped, retry, 1 out of 2. Get weather. So this is an example of if get weather were to fail. Like if you were to try to call the get weather tool and either due to latency or due to the API, the service being down that it was calling, if it didn't get the result that I wanted, what happens? It immediately retries in the tool. And then, oh, get weather successful, boom, it returns the result. This is an example of this like retry and this redundancy being built into the actual underlying agent. Because sometimes these things do fail, right? Like, you know, your internet's down, it's spotty, it's whatever. And you don't want the agent to completely fail on the back of that. You just want it to say, hey, is this like a true failure state? Or was that just a moment in time and the service is actually live and good to go? And so that's just the last example that I wanted to show. The next thing that I wanted to do is I'm going to provide you guys here a deliverable. Let me confirm here. Yeah. Okay. So I'm going to give you guys a markdown file. And what this is going to do, this markdown file is just going to be a Google Doc, right? And what you're going to be able to do with this markdown file is you're going to make a copy of the current agent workbook, right? So everyone has the agent workbook up. Create your own copy, right? Create your own copy. And so if you leverage, you know, the API key for this time being, but you're going to create your own copy, and then you're going to use this link that I'm about to share in the chat now, right? As a prompt inside Claude or ChatGPT, either one. I would recommend Claude. But drop this prompt into Claude, and you're going to want to generate code to augment the current AI workbook into your own agent, right? So the way you can do this, right, is drop that prompt into Claude and say, hey, here's a new agent that I want to build. If you want to be even more precise, you can copy the existing code from the agent that you have a copy of and say, hey, here's the current agent structure. I want to create a new agent, upload that MD file, and then tell the agent that you wanted to do. It will likely give you the exact code excerpt that you can use to paste directly into the entire cell. Now, if you just ask it, or hey, I want to augment my agent to do X, Y, or Z, it's going to give you a code snippet that you then have to insert. And I recommend people try doing that. If you just get the code snippet and you try to insert it, that's like that gives you that deeper understanding of code. Some of you guys might try to insert the code snippet, and then when you try to rerun the agent, it gives you an error. If you get that error, you can try to figure out what that error means. That's the deeper learning piece. Or you can take all that code, put it back into Claude, and say, hey, I'm getting an error. What's the right code? There's a good chance it just gives you the code snippet that you can paste directly into the cell, just overwrite everything that should then run. Okay? And so this is the piece where we're triaging with AI to get something customized and specific to whatever we want to build, even with no technical competency. You take the limitation, you take the error, you paste that back into AI, you say, hey, what is the actual correct version? You take that correct version, you paste the cell. The shell should run. If it does run, you were successful. You used the calculator. Good job. Right? Now, you might not know at all what that code does. That's okay. Does your agent work? When you create your agent input, does that make sense? And so here, let me go ahead and, yes, the video of the session 100% can be shared. Let me provide an example of what so let me just share my entire screen. Can I do that? Let me just share my entire screen.
Is there a reason you've used Python and not a language?
No, no reason. It could be any language. I think Python is like Claude tends to be better at Python. I don't know. This is just an opinion. I have no idea, but like Clock tends to be better in Python. It's also a simpler script that can be run direct locally as well. So how I just want to show folks how we're doing it. So hey, we're taking our MD file, right? Then we're going to Quad. And need to customize this agent to roll on any side. And so I literally just uploaded this MD file. And then I just pasted that prompt that I had from the MD file. So Fable 5 is thinking about it, but I should be using Fable 5. It's expensive. Technically, Opus 4.6 or 4.8 could probably handle this, but whatever. This is that model optimized. I only got 5% left. Using Fable on this is a waste, right? The function. And so it says, okay, at the bottom of cell 2, with def flush against the left edge, it says paste this, right? So I'm going to grab this. Okay. And then here I have an AI, a copy of that initial AI project, just as you guys would create a copy. And so it's asking me to go to essentially this area right here. And with boom, okay. And what else is it asking me to do? And then the schema for the schema section, it's telling me to put that pretty much here. Ooh, I don't think that's right, actually. Actually, it is. I think it is. Yeah, actually, that feels right. Okay. Okay. Just gonna run all. Let's see if this works. So I just inputted those two areas. Just simple code paste, right? I didn't just pasted the code directly in. It's rebuilding it. It's trying the first cell. See if we get the win. Okay, boom, setup is ready. Fake weather tool is ready. Okay, so this worked, right? So I inputted this roll of dice with any number of sides. Okay, so I just inputted these two schemes, right? So now I need to customize this tool implementation line. All right, so let's go ahead and replace that. This is actually much different. Okay, whatever. Just gonna trust the process. Okay, it worked. Boom. And then now for the agent section, say, hey, so for the cell 4, tell me to do this. Boom. Okay. Roll a 20-sided dice and a 6-sided dice and tell me the total. Boom. Right? And what just happened there? It literally gave me, here's your dice tool, ready to paste. 3 pieces, matching the exact shape your notebook expects. The function, paste at the bottom of cell C2. That's what we did here. Boom, bottom of cell C2. Technically, it's not the bottom, right? Instructions could have been a little bit clearer there, right? But then it said, hey, make sure that this is flush against the sides, right? Then the schema, add the tools list in a new item right before the closing parentheses, right? The closing parentheses is right here, right? So just before that, we included the tool schema. And then the tool implementation line, just a straight replace. And then we could test it by asking it to roll the dice. And it worked. And so this could be anything, right? Whatever tool or whatever, however, whatever specificity you want to make to your agent, now's the time to make it. You can make it with Claude, right? And this is an example of how you can augment, right, or build an agent, even if you don't know the exact ins and outs. Like literally, Claude gave me the copy and paste code to put in the agent to create my customization. There's one more version here. This is, yeah, okay, so this is the final version. Okay, subshare. So then the last few minutes, let me reshare.
So, Alan, where does this agent reside? Is it just in Claude?
So no, the agent, I mean, that agent is on your Google Collab workspace, right? Now, that is where you can like essentially test the agent. If you wanted to, that agent, like the four different cells together constitute a Python script. And now you have like a Python agent that you can either run locally, or if you wanted to, you could deploy that right on the web and have a web-based agent that then gives you an input to call. So where it resides is entirely up to you and what you need it for. I would say that, for this, circumstance, like, this might be an internal agent, right? In which case you might want to run it locally. And then that means it's essentially managed and operated through your terminal or your command shell. But where I wanted to end, sorry, here. Hold on, just had a couple more slides. So you built the core, like here's like the rest of the scale, right? What separates the agent you just built from the running in your company or product, right, is memory at scale. This is a big part of like agent orchestration frameworks and like overall like the effectiveness of an overall agent is like where the memory stores, where the context is stored, right? What that agent is supposed to be doing, is that stored in the agent or is that stored somewhere else in your organization that the agent references, right? Evaluation frameworks, right? This means that proof that the agent is effective, more effective, right, than a person would be, or just as effective as a person would be, especially before it sees an end user. So in other words, that agent should be able to validate itself. It's providing output that's going to be valuable towards end users. And then, of course, deployment, right? Running it reliably, observably, and for real. The difference, right, is, you know, an agent that has the proper guardrails and redundancy will be able to survive production, where it has, non-deterministic use cases. And so you just prototyped your idea. The only call out is join us in the operator circle. So there is a Musa Capital operators group that is all founders that are building AI native products. We have additional curriculum even past today's fundamental session that goes into architecture, design principles, execution principles, operator principles, and effectively allow you to not only manage your own production agent in the wild, but also build your own agents internally to scale your companies. And so, to the extent that you want access to more additional education, encourage you. The Operator Circle sessions are always Tuesdays and Thursdays, 6 p.m. Eastern. And with that, that's it. Like you guys have the agent framework. You guys understand kind of like what goes into an agent build. And I would encourage you to build your own. The number one thing that a company can do for themselves, if you're interested in actually going out, raising money, entering the innovation economy, The very first thing you need is a set of agents for internal operations that both build your product and allow you to scale revenue. So this is agents that handle your outbound, agents that handle your code production, agents that handle your internal reconciliation, agents that handle, meeting collaborate, whatever it is. That structure, like that agent structure, becomes your moat as a company more than your actual product in today's world.